In the following slides, we will be considering the posterior pituitary release of antidiuretic hormone, or vasopressin. The functions of antidiuretic hormone, abbreviated ADH, include water retention and blood pressure regulation. So we will begin by diagramming the feedback loops associated with the antidiuretic hormone release. To do so, I'm going to begin by illustrating my hypothalamus and pituitary. This will be the hypothalamus, which is in the floor of the brain, and this is my pituitary. This will be my anterior portion, and this will be my posterior portion. It's important to note that the posterior aspect of the pituitary brain has a neurosecretory cell, which means there's a neuron that begins up in the hypothalamus and extends down into the posterior pituitary to cause cells in the posterior pituitary to release hormones into the bloodstream. What is unique about antidiuretic hormone is that there is an osmoreceptor attached to this neurosecretory cell. And the osmoreceptor is detecting changes in the osmolality of the blood. In addition, this neurosecretory cell also can detect changes in blood pressure. So the neurosecretory cell is responding to changes in osmolality, specifically an increase in osmolality or a decrease in blood pressure, which I will abbreviate BP. Either one of these, either the osmoreceptor that is detecting changes in blood osmolality or the baroreceptor that is detecting changes in blood pressure, can elicit a response by the posterior pituitary in which we will release antidiuretic hormone. This will be abbreviated ADH, but is also commonly referred to as vasopressin. When antidiuretic hormone is released, it targets the kidneys. But remember, antidiuretic hormone is also released into the bloodstream and has a direct effect on the blood vessels themselves. The effect on the blood vessel is to cause constriction. In the case of the kidney, I will get increased water reabsorption. And this is going to occur in the loop of Henle. When I increase my water reabsorption, I have a net effect of decreasing urine production. The idea here is to get back to homeostasis. And the decreased blood pressure or change in osmolality are deviations from homeostasis. So when the blood vessels constrict, they actually are narrowing the diameter of the pipe, and while the overall blood volume may be lower, the area it has to fill is less. Therefore, I elevate my blood pressure, which brings me back to homeostasis. In addition, I'm going to decrease my urine production and have an elevation in my water reabsorption. When I add water to the blood, this is going to help elevate my blood pressure. But at the same time, as I add water to the blood, this is going to serve to dilute the solutes in the blood and ultimately decrease my osmolality. This too helps me get back to homeostasis. So at any one point in time, the osmoreceptor in the hypothalamus may detect changes in osmolality, triggering a signal to the posterior pituitary, or baroreceptors attached to the neurosecretory cells of the hypothalamus may detect a decrease in blood pressure, which will cause the release of antidiuretic hormone. This particular hormone is a protein-based hormone. Pathologies may exist in regards to hyposecretion of antidiuretic hormone. Diabetes insipidus is the clinical term used to describe an absence of antidiuretic hormone. This may occur because the pituitary itself does not secrete antidiuretic hormone, but it may also occur when the kidneys themselves are incapable of responding to the antidiuretic hormone. For example, if the receptors are destroyed, no matter the amount of circulating antidiuretic hormone, the receptor that elicits a response in the cell cannot respond. A person who suffers from diabetes insipidus may have, and likely has, severe dehydration. They'll be very thirsty. Because they also are washing so much water out of their body, the kidney loses some ions as well, and these individuals may demonstrate ion imbalances. Interestingly, a person who suffers from diabetes insipidus may lose as much as 20 liters of water in a day. This is going to be clear, relatively tasteless, watery urine. It does not have the glucose component as you would see in a patient who's suffering from diabetes mellitus. As a side note, alcohol negatively affects the hypothalamus and prevents the release of ADH. This simulates diabetes insipidus for a short-term period. People who drink too much often wake up with a hangover, and a hangover is characterized by dehydration because antidiuretic hormone was not released, and water was passed directly through the body. This accounts for the reason that when individuals consume large quantities of alcohol, they have to urinate frequently. It is possible for a pituitary tumor or some like condition to cause a hypersecretion of antidiuretic hormone. But this ends up not really being a large issue since there are antagonistic hormones like atrial natriuretic peptide, also known as atrial natriuretic hormone, which is released by the right atria when blood pressure elevates. However, if there are elevated amounts of antidiuretic hormone, we will ultimately see fluid retention in the tissues or swelling and edema. This completes the tutorial on antidiuretic hormone from the posterior pituitary.